The first few are really simple because you have two radicals that both square out pretty much. And so when you have something like this and they're already really by themselves, you just square both sides and you end up with just a basic algebra equation that you have to solve. X's to one side, numbers to the other, and you're going to get 9 there. Like that's easy when you have something like that. It's when you start throwing in ones like 5 and 7, 7 being obviously the most difficult of the ones on the first page, or of these three that I chose. For this one, you really need to move this v over. You want to get this absolute value by itself first. So you end up with v minus 8 equals the square root of 14 minus v. You have to square both sides here. The number one error is that people do not FOIL that left-hand side. It is v minus 8, v minus 8. You will have a middle term here, okay? It's not just v squared and 8 squared, which is what everyone wants to do. It is going to be a trinomial. So you're going to end up with v squared minus 16v plus 64. And then on the right-hand side, you do just get rid of your radical there. And now you have a quadratic. You're going to solve a quadratic like always. You're going to move everything to one side so you can set it equal to 0. Add that v, subtract that 14. All right, and you get v squared minus 15v plus 50 equals 0. Factors of 50 that add up to 15. So you're going to get 10 and 5 here, but here's the deal. This is a possibility for an extraneous, and I actually think one of these is extraneous. I think your 5 is extraneous. So you do have to plug these back in and make sure they both work. If I plug in a 10, I'm going to get negative 8 equals negative 10 plus the square root of 4 minus 10, so square root of 2 there. And so negative 10 plus 2 is negative 8, right? But if I have a negative 5 or a 5 here that I plug in, negative 8 equals negative 5 plus the square root of 9 here. I'm not going to get negative 8. I'm going to get negative 2 or something. So it doesn't work. So 5 here doesn't work. So you end up only getting one answer because one of those is extraneous. And so your only answer that you get for this one is, it's not letting me delete that guy because I typed over him, is the 10. So v equals 10 is your only answer. All right. Your 5 is extraneous. The last type you can have is like number 7. Now for number 7, I'm going to scoot that up. You get a positive 2, but you have to do a lot of finagling here to get to that point. Move one of your radicals over so that at least one of them is by itself. Now you could square right here if you wanted to and FOIL those radicals. More power to you. But I would move one over. So I would just do the easiest. That's a subtraction. So move it over. We have 3 plus the square root of 2 minus m equals the square root of 5m minus 1. Square both sides. Right-hand side is the easy one here. This just gets rid of your radical. Over here, it's a perfect square. So you're going to square your 3. You're going to multiply these and double it. And then this guy just cancels out. Right? And so now we want to get this radical by itself. And so we're going to move the 9 over. Well, actually 11 because that's 9 and 2. Move the 11 over. Move the m over. You get 6. Square root of 2 minus m equals, did I add it? Yes, 6m minus 12. If everything is divisible by that 6, go ahead and get rid of it. In this case, it is. Because if not, you're going to have to square it and you're going to have bigger numbers, right? So go ahead and divide everything by this 6 if it's divisible. I wouldn't do it if it created fractions. 2 minus m equals m minus 2. And then you have to square both sides. The left-hand side, I'm running out of room here. The left-hand side is easy. The right-hand side, you do have to FOIL again. And then you have to move everything over and solve. And do you have an extraneous on this one too? Potentially. So we get m squared minus 3m plus 2. So 2 and 1, and I think only one of them works. 1, yeah, because you get 2 minus 1. Yep, so if you plug in a 1, so when you factor this, you get m minus 2, m minus 1. If you plug it back in, your 1 does not work. Your 2 is the only one that works. So you have another extraneous on this guy too, which is why that is your only answer.
Do you have to write like extraneous or just give you 2?
Nope, you don't have to write extraneous. You just have to account for it and cross it out that it's not one of your answers. So, all right, so on your instructions on your quiz, it will actually say, on the quiz itself, I put, give me your maximum number of, I think, zeros, your turns. I actually ask for which ones cross and which ones don't cross, which ones bounce off. I actually have you list those zeros out separately. And then I do ask for end behavior. And then I want you to sketch the graph. And so that's why in your answer key, you're going to see all of this. The maximum number of turns, that's always going to be 1 less than your degree. All right. Then you have to, this part you're going to have to solve for. This part you're going to get from your your degree, right? And your leading coefficient. All right. So your end behavior is going to come from those shortcuts. An odd degree, they're going to go opposite directions. If it's positive, it's going to follow it. As x goes to negative, y goes to negative. As x goes to positive, y goes to positive, right? If it had been negative there, it would have flipped. As x went to negative, y would go to positive, so on and so forth. So that actually tells you right here, this end behavior thing tells me, okay, if on the negative side of the graph, if my y is negative, I'm going to be coming up from this side. That's how I know to do that. And if on the right side of the graph, I'm going to positive infinity, then it's going to be from that direction, right, that I'm coming with this graph. For your zeros, zeros literally mean where this guy equals 0, all right? Where that equals 0. So I need to factor it. If I have a common factor, I'm going to take it out. In this case, an x squared plus 6x plus 9. And then I want to do my basic factoring. So my basic factoring here would be x plus 3, x plus 3. Each one of these tells me where I have a 0. So you'll notice that I have up here in my answer key, my real zeros, I have 0, which is, I get it from this. And then I have negative 3 multiplicity of 2 because I have a negative 3 and a negative 3. All right? So then I can answer the next question with that. It crosses the x-axis at 0 because that's an odd multiplicity. It doesn't cross it at negative 3 because it's an even multiplicity. All right? And so that is going to help me figure out then what happens here. So I'm going to negative infinity on this side, and I know that from my limit. So I'm going from negative infinity. I get to negative 3, and I bounce off the graph, which means I have to turn. In order for me to cross it at 0, I'm going to have to turn somewhere in between negative 3 and 0 because I have to get back up to 0 to cross the graph and keep heading up to positive infinity. All right? So that's how those bouncing crosses and end behavior help you sketch that graph. You don't even know where the max and mins are at this point. We haven't done that. So I'm just looking that somewhere in between those you turn. Okay? Somewhere in between those you turn and go back up to where you need to cross. So anytime, I did not tell you how to divide here. You may do it however you want, whichever method you want. Some will lend itself to one way or the other. Anytime you see something like this, you're going to want to do synthetic because you can just set that guy equal to 0 and you can do synthetic with negative 3. It helps to write it down, okay? So if it's just leading coefficient of 1 there that you're dividing by, you're probably going to want to do synthetic division. All right, so I'm going to do negative 3. I have an x squared, that's 3. X, that's 11. Constant, that's 3. And then I can just do my standard drop it. Hopefully I did all those correctly. And don't forget that when you do that, you have to do it one down from where you started. I started at a 2, so I have to do x to the first power, 2 without anything. That remainder goes over what I was dividing by, and that's where I get this answer right here. Okay? Now, typically when you have a leading coefficient, you will want to divide long division. Long division is just what it sounds like. You have this crazy, ginormous guy on the inside. Make sure that if you have a 5, then you have a 4, and you have a 3, and you have a 2, and I'm running out of room, and you have a 1, and you have a constant. You have to have all of those things, okay? And then the 2x plus 6 goes on the outside, all right? And you're going to do exactly what long division was in elementary school, just slightly more complicated, right? Look at this 2x, how many times you have to multiply it to get 2x to the 5th, x to the 4th, and then you're going to distribute through and just go all the way down, all right? You can do synthetic division here. Set 2x plus 6 equal to 0. You're going to subtract 6, divide by 2, x equals -3. Here's the thing. If you do something like this guy gives you a whole number, -3 to divide by, and you can certainly do synthetic division, divide by -3. However, anytime it has a common factor, like this guy has a common factor of what? 2. You're going to have to divide all of your coefficients by 2 when you get to the end of this guy. And not your remainder. Your remainder is not divided by that. But all of your coefficients you have to divide by any common factor that you have, okay? So sometimes that gets a little tricky, right? So just either way, you could do long division or synthetic, it's okay. And I will say too, for ones like 16, that does not have a common factor, you would actually have to use +3/4 if you did synthetic division there. You would have to do synthetic with a fraction, okay? So if you're not comfortable with those little caveats of always using synthetic, then you may want to use long division when you have a leading coefficient and use synthetic when you don't, okay? Because you will on your quiz have one that has a leading coefficient and one that does not. So choose your method, but you're welcome to do it with fractions or to do it by dividing with that common factor at the end. Synthetic substitution means do synthetic division. You don't change the sign here, okay? Synthetic substitution also, your answer is only your remainder. All right, so your answer is only your remainder here, okay? So I am going to use synthetic division here. X cubed, my coefficient is 1. I do not have an x squared, so I have to put a 0. X, my coefficient's -15, and my constant is 22. When they give it to you like this, you do not change the sign. Use a -4 there, all right? And then you're just doing exactly what you've done the whole time. All right? But your answer here is only that remainder. So you'll notice the answer is just this piece of it. It is not anything else. You do not put your x's back in. It is asking for the remainder because the remainder represents what would happen if you plugged in a -4. And you can check your work by plugging it in, but you can only check your work that way because it specifically tells you to use synthetic substitution. So if you just go in and you say, oh, well, I'm just going to plug in a -4, this is how you would want to check it, not how you would want to do the process, because I actually here told you you must do this process, okay? So you can check it this way, though, and you should get 18. And it's a good way to check your answer. Just plug it in, all right? But what we're looking for these is the remainder. I'm going to do synthetic division here. Always what equals 0 when you're doing this one, and then do it straight down. So we're going to have a 5 multiply. We're going to have a 3 multiply. You're going to have a -12. This is not 0. That's why my answer is no. Okay, so the process is exactly the same as synthetic substitution. I just am answering a different question. Yes or no, is it a factor? All right, so for this one, they give you the zeros and you just have to FOIL. Literally just have to FOIL. Now remember, if they give you the 0, you're always going to say x minus that number. So x minus 5, x minus a negative 1, x minus 3 halves. You do want to simplify before you start FOILing. Okay? So I'm going to x minus 5 is as simple as it gets. Here, x minus a negative 1, well, I'm going to write that as x plus 1. And here, remember, you multiply both of these by 2. So multiply by that denominator, 2x minus 2 times 3 halves. Multiply both of those by your denominator. So you're going to end up with 2x minus 3. 2x minus 3, unless you just desperately want to FOIL with a fraction. I would not. All right, and then just FOIL. X times x is x squared. X times 1 is 1x. Negative 5 times x, negative 5 times 1. Simplify this before you FOIL again. And then just distribute again. I'm going to do the smaller to the larger. So 2x times x squared, 2x times negative 4x, 2x times negative 5, and then distribute your negative 3. Negative 3x squared, positive 12x, positive 15. And then combine your like terms. So we have 2x cubed can't combine with anything. Negative 8 and negative 3 give us that negative 11. Negative 10 and positive 12 give us that positive 2. And then I didn't write my 1, but that's a 15 that can't combine with anything. And that gives us the 15. All right, so this one is literally just FOILing. You're just FOILing through, okay? Just make sure you set these up correctly.